Hi, I'm Chad Landis, and I'm from Capital One, and I'm here to talk about how we do mobile development at scale. So first, just a little bit of background about our applications. We have both an iOS and an Android application. These are rich native applications with a beautiful design, and this is how our millions of customers service Capital One on a daily basis. They're native applications. On the iOS side, they're built with Swift and leveraging UIKit directly. On the Android side, it's a mixture of Java and Kotlin, headed to a full Kotlin application over time. These code bases date back from 2014, and we'll talk about some of the interesting challenges along the way for that reason. But first, I want to talk a little bit about scale, because scale is a relative thing for everybody. So just to give some numbers in terms of our applications and our organization, we've got over 100 features in each app. They're separate code bases, of course, but we have about 150 plus developers in each code base. On the iOS side, we've got about 1.7 million lines of code, including tests. And we average about 17 pull requests a day that are getting merged in over a 30-day period. So it gives you an idea about the size and scope and scale of contributions into our code bases. But I want to talk a little bit about how we got started and where that came from. So originally we had a team of 5-10 developers in each code base. It was a much smaller application than the one we have today. But we built that, shipped it, and then over time we added more features, which of course means you add more developers, and the process kind of repeats. And over 2, 3, 4 years, we continue to grow, and we start bumping into some challenges as we start to scale up. And of course, everybody's favorite merge GIF. All kinds of interesting, unexpected challenges come along the way once you start adding just more and more code, more and more people. So let's talk about some of those specific challenges. Long build times, pull request queue backup, complicated dependencies. All these are kind of foundationally rooted in at least 4 critical things. So first of all, the project structure. It's just complicated. It sprawls across various repos across our internal GitHub organization. It's time consuming and kind of almost confusing to figure out exactly where your contributions have to land to get things moving. The application itself, the code, was very monolithic in nature. So with a lot of coupling and unexpected and unintended overlap across features, a lot of shared code, and just makes it really difficult to make changes without a lot of coordination. We also had not as much coverage as we would like from a testing perspective, and so you end up with defects slipping through, especially over time as we get more and more contributions. It was just becoming a bigger and bigger challenge to make sure things were working as we expected. And as I kind of alluded to with long build times and PRs backing up, like the tooling, both for local dev and on CI/CD, was just a real challenge. We kept bumping into the limits of both the tools from Apple and Google as well as our own infrastructure, and it made it difficult. So when we talk about all these challenges, we kind of had that step back moment and we realized we didn't actually build or structure ourselves to have this many contributors and this many features. We had a small application that grew over time, and we never really did that step back moment to figure out, are we really building the right way? And we kind of came to the conclusion that in order to solve these problems, what we don't need is just an application, but we need the right platform and the right foundations, tools and frameworks and capabilities that we can then build features on top of. And that's really the key to operating at scale. How do we convert our application into a platform? What are the things that we need to invest in to be successful at scale? Addressing these problems kind of one by one, I mentioned that the project structure was complicated and kind of messy. We had repos all over the place inside of our internal GitHub organization, as I mentioned. So for us, the way we address that is with monorepo. And so instead of having our code spread all across all these different places, we want the code that's required to build the iOS application to be in one repository. All the code that's required to build the Android application to be in a repository. And that kind of unlocks a lot of interesting things. This slide kind of gives you a rather shocking but realistic view. On the left side is the iOS graph at one point in 2018, 2019. Just kind of shows you the number of repositories that are there. The one on the Android side looks a lot more extreme. Of course, it's also referencing all the dependencies that come from the larger Android ecosystem from Google. but it's in a similar boat. We had about 60 repos at one point on the iOS side, about 110 on the Android side. And to be very clear, we're not talking about like third-party code here. This is our own code. It's just organized and spread around separate individual repositories. That's just the way you do things. You have this module of code, it has its own repo, and that's where that goes. So you end up having to maintain all these different repositories, all these different separate pipelines. And then when you want to make a change that's pretty foundational, like bump the min SDK on the Android side, or update to a new version of Xcode, or address changes to the Swift syntax on the iOS side, you end up having to generate 60 plus pull requests and coordinate them and land them in a specific order. And it's just this incredibly laborious process just to kind of move things along. So what do we really want? Our destination state is, again, that consolidated code base. And then we can start to leverage graph-based build systems to do dependency analysis, and then optimizations with like caching binaries for faster builds. But essentially, we want to stop synchronizing and human-to-human coordination between multiple repositories. We want to stop using semantic versioning, which is a useful tool, but doesn't really scale up when you have that many modules that are interdependent upon each other. It works pretty well for dependencies really low in the stack, but as you start to add more and more modules that are in the middle of your tree, it really starts to break down, and you spend a tremendous amount of time with bookkeeping and other tedious work. What we want to be able to do is make these broad, sweeping changes in an atomic fashion and use our compiler and our test suites to tell us, yep, everything's looking good, go ahead and merge, rather than tools that are out of band. And then this kind of simplifies the refactoring story. It simplifies the dependency upgrade story, as well as just making it a lot easier to move around and contribute in the code base. So on the iOS side, we've gone from 60 down to basically 11. All the actual feature code is really in one repository, though. We have a couple last hanging around lower dependencies, and those will be moving in over the next couple of months. On the Android side, this work is basically done. We've gone from 110 down to 1. And it's just been a dramatic simplification of our storage, and it unlocks a few more things to come. So we solved for monorepo and code storage. So how does this work now? Do we just have like one big module? Is everything thrown together? It's actually kind of the opposite. As we bring the code together into one repository, we actually want to break that up into smaller modules. So right now we're dealing with a tightly coupled monolith where everything's kind of interacting at one time. And instead we want to break that down. And so for us, the solution there is something we call a toolbox. Before I go into more detail, I have to put up the obligatory quote with enlarged font said by a very smart person, so we can all talk about that. But again, in this case, we're talking about modularity and we're talking about functional programming. But I think if you zoom out, you realize the statement applies to pretty much anything in our field. We always want to take things, break them down into smaller pieces, talk about inputs and outputs, think about better local reasoning and understand exactly what this piece of code or this module is doing. And then I can compose larger things from those smaller pieces. In a monolith, that's just really hard to do, to understand how things are working, what they're actually doing, and it gets hard to work with due to all that coupling. So I reuse this slide here again as a way to set up the framing, and also because I love the get merge gif. Fundamentally, we have a bunch of code that's composing of a bunch of features here, and a bunch of developers are all kind of like jammed together here in this monolithic architecture. And we want to break that down into 4 separate modules in this case. And I've got different developers and different teams working on different schedules and building and shipping their code as they see fit, but they're no longer as tightly coupled. And they have the ability to focus on just their feature and just their code and not have to worry about, the collisions, the merge conflicts, and the challenges of all being in that one shared space. And so what we want is to transition from that monolith architecture on the left, which is the, hey, I've got my collection of app, shell, platform code, and then a bunch of feature code. They're not really discrete modules. They're collections of code, but it's all in one compilation unit. It all kind of comes together, and feature code for feature A can kind of reach into code for feature B, and there's really no clear boundary there. And I run into all kinds of challenges when I do that, in addition to the tight coupling. What I want is on the right, and I've got my platform code, and I've got my features delivered as individual plugins. And they're packaged as separate modules. And now I've got these nice clean boundaries, and I can even do things like using lint rules say, hey, feature A is not allowed to reach in, touch, use, reference anything in feature B. And I have this really nice separation, and it keeps things nice and clean, nice and flat, and nice and separated. And I get build time benefits from that with build speed, as well as better understanding at runtime. So we talked about Toolbox, and it's really the way we apply the pattern of modularity to our code base. Toolbox itself is actually many things. It's command line tools, it's runtime frameworks, and all those things kind of come together. So now I think about my feature as a plugin. It's this kind of discrete module of code. It ends up being packaged up as a separate module, a separate compilation unit. And inside there, I have all the code that I need to implement my feature. All the different views, the logic, the data model, the API requests that I need to make to get my data to service my feature. All of that is kind of co-located in one module. Now, there's a lot of things I need from the broader application, and that's provided to me at initialization time. The toolbox gives you this environment object, and on that are a bunch of things that I can use throughout the lifecycle of my feature. So there's a bunch of shared services on there, like the ability to access feature toggles, the experimentation system, if I have A/B tests going on inside my feature, content manager, so I can fetch assets efficiently from our CMS, the monitor capability, so I can log and monitor features in production. And so if there's errors occurring in production, I can send that back off board, and that'll show up on my dashboards. All those kind of services are available to me. We didn't start with all those. Those have been built out and enhanced over time. But anything that's kind of generic and shared lives in one spot and comes in and injected into my feature that way. I've also got the application router, which is a pretty foundational and important piece of how the application comes together. So we don't want module A or feature A or plugin A to reference plugin B directly. So instead, if I want to transition from plugin A to plugin B, I would use the router to say, router, please present this plugin, and I'll use a route or URL to reference that. So I get this much lower coupling, both build time and runtime. It allows me to reorganize and restructure the application. And as a feature dev, I think less about exactly where my feature lives in the application and just try to think more about my feature and the transitions to and from other surrounding features. And the router is the piece that kind of sews things together there. And it also gives me deep linking, mostly for free out of the box, because we're using routes to address all of our features. There's a couple other services there, a repo, which is an efficient in-memory cache, and a couple other things. But the most important aspect of Toolbox are the delivery rails. And this is really the thought of, I package up my application in this plugin. I use the router to kind of instantiate it and present it and get it on screen. But when you think about it, whether I'm running on a customer's device inside the full-fledged application alongside a bunch of other features, or whether I'm running on a development machine in like a test harness environment, where the only thing that's really there is my feature and I'm inside an emulator or simulator, or I'm running on CI/CD, also inside of a test environment, no matter what, my plugin kind of thinks and operates the same, but the environment that's injected into me could be configured quite differently. It could be real, hitting real services. It could be mocked out, stubbed, whatever's appropriate for that environment. So when we try to think about our features now as just these modules that get deployed into the application, and that environment object is our view to the outside world, it becomes a lot easier to think about all these different situations. So how are we doing along this process? We started with that monolith on the very far left. At this point today, we've got over 100 different plugins in the application. So we're chipping away at that monolith, making some great progress. We have the Toolbox platform inside the application and a bunch of modules that are there shipping to customers. And our destination state's on the far right, where that monolith is now gone. All the features have been relocated into feature modules as plugins. And then we now have this nice, clean application that's no longer monolithic in nature, but actually quite modular. So we talked about code storage, and we talked about macro level architecture of how we kind of structure and break down the application. But we haven't really solved for that low test coverage challenge yet. And so the building blocks there is a specific architecture pattern that we call reactive store. And we noticed that we didn't have great test coverage. Well, why is that? Oftentimes, poor or lack of clear architecture is the reason for that. Taking a look at the code base at the time, we had a collection of patterns. Across iOS and Android, we had 5 to 6 different patterns in there. And we didn't have any clear standards. We didn't have any clear guidance. and we had a lot of flexibility on how people were building. And that was a real challenge for us in terms of like maintenance costs and kind of maintaining and supporting all these different patterns. And so in order to operate at scale, we realized what we needed to do was have kind of a standard pattern that we use consistently across the board, and most importantly, something that's going to help us on that testability story. So we looked around at kind of the different options, what was around in the larger community as well as in the iOS and Android communities too, trying to see like where things are going. We were obviously inspired by Flux and Redux type patterns with universal directional data flow, and obviously reactive programming as well is becoming more and more of a commonplace. Reactive sort is kind of a combination of a couple of those different concepts pulled together, and it's an asynchronous unidirectional data flow architecture. And the heart of it is the store, where you basically model the fundamental logic of your feature as a series of actions that manipulate state. And all the transitions that occur to your features, logic occur there in the store. There's a pure reducer function there that's super easy to write and super easy to test. And then we have the interpreter and the presenter, which are the pieces that also interact with the store. And the store, the state coming out of the store is mapped by the presenter to things that are presentable. The view is really just binding to the presenter. And then as the user interacts with your feature, button taps, gestures, sliding, dragging, the view just emits these generic events, and the interpreter takes those and maps those into actions which are actually pertinent to your feature's domain. So it allows the view code to be as far away and separate from the actual feature logic that you want to test. This is one of the biggest challenges with doing mobile development. The view frameworks are just so common and so ingrained that you end up, that code kind of creeping into your logic, and then therefore it creeps into your tests, and it becomes a real challenge. So the point here is separation of concerns, putting the right things in the right places, and then enabling really, really easy testing. Every component on this screen is super easy to test. So I can drive inputs and outputs and assert that everything is going correctly. And then the view itself is really just a collection of reusable components. So we have a universal design system that our designers have worked on. It's a beautiful and it's aligned design across all of our channels, especially with iOS and Android. And we have a concrete implementation of those. So, primitives like fonts and colors and icons, as well as larger, more reusable components, buttons and rows and chips and all kinds of things. So what's really nice is these things are, accessible, and light mode, dark mode, and multiple resolution. All those things are already accounted for, and they're already tested on their own right. And so inside your view, you're just instantiating and using these things and hooking them up to the bindings from the interpreter and the presenter to make sure the right things are happening. So as a developer, you're not having to write this code again and again and again. So why are we doing all this? Again, we've talked about testability as the big angle here. So now I have the ability to do targeted testing. So on the left, in that monolithic structure, I've got a small change in the lower left corner, just a couple bits of feature code. But because I have no way to determine what has changed or what the impact is, I have to sort of naively build and test everything and come up with my answer. Because we've done the work to be smart about the way we store our code and structure it and break down our code into different modules, I can then run my tests on just the things that have been changed. And I can just build and run a smaller portion of the graph, get to an answer quicker. But because I've got highly testable code, I have a lot more confidence that things are actually working as expected. So test automation is kind of an essential for operating at scale. This is that aspirational pyramid that we always see documented in the literature. We're starting to approach that now with, really plussing out the unit test portion and having high quality unit tests that even test all of our logic, which is the most important place and where your bugs kind of show up. So we've solved for code storage. We've addressed our large level microarchitecture, and we've gone after our test coverage challenge. And so what's really left from a developer ergonomic and ease of use case is our tooling in terms of how slow the builds are and merges being such a challenge to land. So what can we do in that space? So obviously there's CI/CD and build tooling that we've got to build and enhance and augment to address that. A couple of quick examples. We have a multi-merge process for our PRQ. The pipeline's pretty clever. Instead of trying to merge each pull request individually, what we'll do instead is take a number of pull requests, run a bunch of checks on them, and say, verify they have all the right approvals, they pass all your lint checks, all your security checks, and then you mark them as these are, fit for merge. And then the multi-merge job comes along, grabs them all, pulls them together. It might grab 5 or 6, merge all of those together, and verify that the merge is clean, and then we run all the build and test checks that we need. At that point, if everything looks clean, then we can merge, and that will close those 5 or 6 individual pull requests all in one shot, instead of having to try to run all these in series and each one invalidating the other runs in parallel and trying to deal with those large queues. So this has been a real help in terms of really increasing the productivity of the pipeline. But of course, as the tools change and the frameworks change, this is constantly being evolved and enhanced and obviously measured in all the different areas. In terms of custom build tooling that our developers use, on the Android side, we make heavy use of Gradle, and we've got custom scripting and custom plugins that allow us to say, hey, I'd like to pull down just the source for these 2 modules. Everything else can be binaries, and those will come down from Artifactory or a previously built thing, or pull something from the Gradle build cache. So I'm only building a small amount of source that I'm going to be focused on for building and iterating and debugging, and everything else, doesn't matter to me. So as a dev, I'm building way less code, and I can move a lot faster. On the iOS side, we have a custom command line interface that we use to run a bunch of different scripts and assemble and set up your development environment correctly. And this will also make use of Xcode Gen to actually generate Xcode projects. So kind of in a similar manner, you can say, I would like just these 3 modules, right? These plugins are the ones that I care about. And then we'll set up a development environment that has, all the dependencies you need, plus those 3 plugins and your test targets and nothing else. So you're just building and running the code that matters to you instead of the entire build graph. So we've addressed all these big pain points. So everything's good and it's done, it's perfect, and there's no more problems, right? Obviously, that's not the case. This is software, nothing's ever done. And, everything isn't working as well as we'd like. Build times are still our biggest pain point. We'd love them to be, to come down even further. On the Android side, we've got plans to leverage the Gradle config cache. On the iOS side, we're actually looking to bring Bazel into the build graph to kind of give us a lot of the similar benefits that we get with Gradle. We've been working on this for quite some time and knocking down some of the barriers along the way with code storage and modularity. And we have about half the graph is now working with Bazel. So with this, we'll get a build cache and dependency analysis and a lot of other niceties that are part of the next generation of our pipelines. It's also important to point out that the platforms that we build upon from Apple and Google are also constantly changing, and we need to adapt with those. So we don't try to abstract away the underpinnings of those platforms. We embrace and we leverage, Kotlin and Swift and the frameworks directly. And with Jetpack Compose and Swift UI, these are the new frameworks from Google and Apple to build, declarative UIs. We want our developers to be able to use those. So how do we evolve Toolbox and Reactive Store to take advantage of those while still giving us our testability wins and keeping us on our platform rails? So looking to continue to evolve those as we go and embrace those new technologies. Also, in terms of our test pyramid, we wanted to be able to do add-in integration tests in the pre-merge state. The challenge there is if you're hitting live services, you run into all sorts of stability challenges. And so contract testing from Pact, which is a tool we're looking to integrate, is a nice solution there to add and bolster our test pyramid without slowing down the pipeline. So I talked about a number of things here today. Hopefully, it gives you a little bit of a glimpse into the path that we've been on. Every organization is different. Every code base is different. We've certainly benefited by kind of looking at what others have done in a similar space, operating at scale, and hopefully you can glean some insights from the steps that we've taken. But we made a lot of progress, but obviously we still have more work to do. And I guess I will say we're hiring. So if you're interested in helping us build out the platform or build some really cool features on top of it, certainly get in touch. And with that, I'll just ask if there's any questions.